Then we're going live. Hello, everyone. 1 second. My name is Vladimir, and you're on YouTube channel Architecture Weekly. Today we're speaking about integration testing, and I'm having Oleg Šelajev here with me.
Hi, everyone.
Yeah, so microservices, integration testing, test containers, and all that stuff. We're having an exciting hour. So let's start. Oleg, please introduce yourself.
Hi, everyone. My name is Oleg Šelajev. I live in Estonia, which is a very good country. Vladimir can vouch. And then I work as a developer relations person at Atomic Jar, which is a small startup. Interesting startup. We do developer tools, and one of the main sort of claims to fame that we have is that the company was built by the maintainers of the test containers libraries. Test containers libraries give you the API to do stuff with containers, right? So a programmatic way to manage containers, configure containers, start containers, and so on in your application lifecycle or in your application tests. We target pre-production use cases with those. There are libraries in different languages, open source libraries. And then Atomic Jar as a company maintains the libraries or supports maintaining the libraries where we don't have the official maintainers within the team. And we build tooling around that to simplify working with those. So this gives me quite a bit of visibility and kind of sort of forays into talking to people about their testing practices, how they, like, do they have confidence in tests? Like, how do they test? And also opens like a lot of interesting discourses, like, what is a unit test? Does it matter? Should we be just doing tests? And so on.
Okay.
Do you need a staging environment? And so on. So those are sort of the main questions for the test containers libraries. With the recent, well, how recent? With the last 10 years, right? A decade of microservices, testing has become much, much harder, I would say. And even though we are, as an industry, I think we are in a better shape now regarding the actual running productions environments with microservices, right? Because everyone does that, and there are like a ton of know-how and approaches for production. I think much less emphasis was put historically on developer experience, on setting up like sort of those distributed systems for developing applications locally. And this is where test containers and Atomic Jar, I feel, can help quite a bit. Before that, since this is not about Atomic Jar, but more about me, before that I worked at Oracle Labs doing the GraalVM thing. So I'm fairly passionate about runtimes and virtual machines in different languages and this and that, following WebAssembly developments recently. And then, so yeah, virtual machines. Yeah, that is it. Programming. Okay. I play chess in my spare time, but poorly.
Poorly is like where you are at the rating.
Well, doesn't matter. It's just a number. It's not about the number. It's about the process of crushing the opponent and then seeing defeat in their eyes when they realize they cannot do anything.
Yeah. Same with StarCraft. Like, you're just forcing a person to leave.
Yeah. No. Okay. In the childhood, I sort of played semi-competitively for Estonia. That needs to be said. That is a fairly big qualifier, right? Because Estonia is small, very often smaller than maybe even some cities in the world.
Yeah.
And I wasn't even top, right? So I was just sort of playing.
Okay. You don't define yourself through the competition, so that's okay. Yeah. Okay, that's very interesting story. So let's start with the beginning. Okay, So back then we had monolith applications, and we kind of understood how to write tests, and they were not even like integration tests, because you're not integrating anything. You would just write a test that would, call several modules, and that would be fine. What challenges for integration testing came with this microservice transition?
And this is interesting. I would like to challenge you. Did we know how to write tests for monoliths? Do you so you're running like a team or a couple of teams, like a division at Bolt, right? Like people who actually develop software, right? And you have test suites for that, right? Like those teams write tests and do that.
We do, yeah.
How much confidence do you have in your tests? When tests are green, does it mean you deploy automatically?
We pretty much do, but then we still run some manual tests by operation people, and and we even show, like, our systems produce documents, right? So at the end we need to show the documents to the tax advisors and to the local people in the countries we're issuing those documents for, to make sure that everything is actually correct. And this is like a big gap that I want to close in the next quarter, let's say.
Right. So you are in a very, very kind of sort of advanced spot where you not only, like, I hope, like, as an industry, mostly, we figured out that the broken tests, red tests, are a signal. It means that stuff is broken.
Yeah, right? That's definitely true.
So, well, at least, like, I would hope, right? There is, like, a boy can hope. But also, the green tests very, very often aren't actually a signal that everything is right. And if you look back at, like, when in the times where microservices were new and then how people develop software, I think very, very often you still wouldn't be able to say that, oh, we run tests are green, and that means everything is working and we're confident in this. So you only get like half of the signal from your test suite. And I think that is a pretty big problem, because you actually, like, you don't derive quite a bit of information from the tests. You don't know why you run them, and that is specifically the problem with unit tests. If you test your system in isolation, if you test just pieces of code, then the broken test signal tells you a lot, right? But like the green test doesn't actually signal particularly that much. And of course, it depends.
Well, green tests tell you that every piece in separation is not broken by itself.
Yes. Yes.
So it doesn't try to tell you that everything works. It just says that the parts are healthy.
Yes, of course. The parts are healthy. But like, you run the system as a whole, and then that you need additional assurances. So for that, in the past, not even now as well, right? We run integration tests and maybe end-to-end tests, or sort of like how some teams call it, integrated tests, where they run in actual environment similar to production. So sort of like an automated test against like a fully like staged environment, something like this.
Yeah, we call them cross components test.
Yeah, where you can have that. And that was also how people organized their test suites in the past. You would have a monolith and you would run it against your database and your like enterprise bus software that to send like SOAP messages and things. Sorry, my experience is mostly in Java. That's where the things, and you were like and you will test it against that in moderate isolation. So you just run the components of the system that are adjacent to the application you're working on for the test, right? So now with the microservices, with the rise of microservices, that became much more important, because a large chunk of the logic of a whole system became encoded in the behavior of multiple services.
Yep.
So, and to test those interactions, you don't have like a lot of approaches. One is still to do those like cross component larger tests where you will spin up the whole environment, and you are lucky if you can spin up like not the whole cluster, right? You get you
That's
don't need like
expensive. Yeah.
yeah. It's also frankly very often impossible, right? You cannot pretty much spin up another maybe Netflix or another yeah, Netflix is a good example. Another like the whole Bolt like production system, like it's just impossible. Maybe I don't know about Bolt, but say like with Uber, it's probably impossible to spin up another Uber for the tests, because there are like could be some cross dependencies, cycles, and so on.
But you don't need the entire system for any particular test, because like Bolt or Uber or Netflix is actually separated into subsystems, right? So for Netflix, for you have a subsystem which streams videos, right?
Yeah.
Then there's a system that is doing payments, and those two are not really connected, right? Then you have, I don't know, a review system, which is not connected either. So
yeah, but like they could be connected in some sense, right? But like even like what I'm saying is you need to spin up like a large chunk of your production system, and then your interactions become and your tests become very error prone, fragile, right?
Yeah.
Because the main idea for me as a developer when I'm in my inner loop, right? I'm developing new features, I'm fixing bugs. What I want to do, I want to have tests that will only fail when I'm doing something wrong, when my application is broken. As soon as I start depending on other people's software, and that is not stock software like, I don't know, databases or like a message broker, and this is not even sort of other services that maybe my colleagues maintain, but that are stable, like a configuration server. A configuration server almost never changes. It's like it's a finished software, right? So on those I can rely in my tests, in my automatic tests, with pretty good confidence. But as soon as I start relying on systems that are under active development by other people, or by also me, but in a different project, then my source of failure becomes non-deterministic. Well, or not non-deterministic. It doesn't necessarily start from my application.
Yeah,
so running
you said you want an understanding that if the test fails, then something is clearly broken, and but we don't really understand what does that mean, right? What does broken mean?
Well, yeah, it means that my assumptions about the behavior of the application were not, like, the reality didn't correspond to the assumptions.
Okay.
Right.
What's the source of those assumptions?
Yeah, well, written in the code, right? But the important part here is that what I would like that the mismatch between my assumptions and the reality, it should come from my application while I'm working on it, right?
Okay.
And then I can fix maybe my application behavior, maybe the environment setup in the tests, maybe the actual assumptions how the software should work, because maybe my understanding while I was writing my code or my tests, my understanding of how the review system should work.
But I want to argue actually. So I'm not sure if the application itself should be a source of those assumptions. From like an architect perspective, the source of assumptions are the requirements, right? So we first, like, somehow we like get those requirements either explicitly or implicitly, right? So we either have a document with written requirements, or we kind of agree with other people like product managers or our colleagues or whoever it is, that's like we intend to do this, right?
Yeah.
And then the code is like our attempts to express those requirements.
Yes.
So
yeah, we will get to that point as well, right? My main idea currently is that I don't want my test to fail because of some other applications, right?
Yeah.
Because then I'm bottlenecked, right?
Mm-hmm.
So this is, I want my integration tests to, or whichever tests, to fail only if I can actually fix them, right?
Mm-hmm.
Whether that fixes the application logic or whether that fixes the test itself, right?
Yeah, that's a strong proposition.
Those are different things, but like this is what will give me as a developer the most happiness, because then I can work and I know that I'm in control of my destiny.
So what you actually want is like you want to fix the perfect behavior of all the components you depend on, and like check only your piece of code that you're working on right now.
Yes.
Mm-hmm.
Yes. And then I would argue that it's really, really hard to get tests that operate this way on sort of the unit test level, because then most of the external systems or external components things are implicitly assumed, because I'm only testing small pieces of code at a time.
Wait a second. Let's figure that out. So for unit tests, like the typical practice is that we're not using actual external components, no databases, neither Kafkas, nothing. We're just assume they behave this way, and we just replace them with mocks or stubs.
Well, this is exactly what I said, right? We assume the behavior of external systems, and we don't actually check them even on the basic level. So there are a lot of assumptions going on in there, and it's also and it's also hard for me to get this say this isolation of my application and tests in a staged like environment, because there are other people code involved, and then something will break and nobody knows what actually was the source of the errors. So the integration tests hit this like sweet spot between having the system that gives you a reliable signal whether parts would work, right? But also maintains the sort of the developer experience of creating those.
Okay.
And in the past, like, so, and this is specifically, as I was saying, this is specifically true for microservices. In the past, it was also, well, it's also true for monoliths as well, because they still do need to work with external systems, databases, message brokers, and other services. But for microservices, that is extremely emphasized, because if your service is small and does like a few things well, right, it means it relies on maybe more other services than a larger application. Right. So what was the question? How did we start talking about this?
We started talking like how this complexity of integration testing came with microservices.
Yes. So and then with microservices, because there is way more communication patterns between different components, services need to talk to each other. And then with the rise of microservices, the rise of the cloud technologies came to be, right? So now everything talks to everything with like a myriad of different ways. Instead of calling like a neighbor class with just a new object dot something, which is much simpler, and that all emphasized the need for integration tests. I think there was an excellent blog post by Spotify where they talked about how they started rethinking their approach to testing, specifically for the microservices. Remember, in the past there was like this testing pyramid, right? The testing triangle, because it's flat.
A lot of unit tests, some integration tests, and end-to-end tests, like in a few numbers.
Yes. So what the Spotify team discovered for themselves is that they would switch the composition of their test suites, and they described it as a honeycomb. They still do like unit tests, which they call the implementation details tests. So when you have complex logic that you would like to test in isolation, whether that could be like, I don't know, like whether your machine learning system gives you decent outputs, right? Or whether your compiler compiles a snippet of code to like machine code.
Yeah, that's useful,
right?
even at a very basic level when you're just doing some JSON transformations. Even there, unit tests can be really useful to at least test all the edge cases. So that's still fine.
Absolutely. So like you have some implementation detail tests, but then the chunk, like so the middle of the hexagon, is the integration test, which is the bulk of their test suites, and which is what they use to make the decisions about the code quality.
Okay. I will need a link to this article later, so we can include it in the notes. But that can be done later. By the way, for the folks who are listening to us right now, so feel free to put the questions in the chat of the stream on YouTube, and we will try to answer them with Oleg. Okay.
Artyom was saying, just verify everything and then suffer when the integration happens. Yeah, that's also an approach. You can. There was this like a really thought-provoking quote that I saw somewhere. I don't think it's attributed to a particular person, but it goes like this: everyone has a test environment, and some people also are lucky to have a separate environment they run production in.
Yeah.
Which is if you don't test enough, you test in production, and then if you can tolerate like downtime, if you can tolerate annoying your users, and if you can tolerate like erroneous behavior, then well, Godspeed.
Actually, the folks from observability fields like Charity Majors, and we have an interview with her on this channel as well, so check out. I will add a pin probably in the in some of those two corners. I don't know which. They actually say that, hey, test in production, because this is the best environment that will give you the most signals about what actually happens.
Yeah.
So there are different opinions on the topic,
and I support that. But that doesn't, like in my interpretation, that doesn't mean skip tests entirely. It's not like write code and throw it into production to see what happens, but I think what it means, at like a sensible interpretation of this, is that write a code, write your tests, have your CI environment, your continuous integration thing, to be the source of truth for what it means the code actually sort of works.
Okay.
Right? Run your tests to the point where you are sort of clear that stuff is working, and then deploy it to production. So skip staging. That's what I hear when they say like test in production. Don't bottleneck on staging. Don't bottleneck on manual operations. And then of course, like it doesn't necessarily work for all industries or for all use cases, right? Sometimes you have to have like somebody responsible for pushing the button. But test in production doesn't mean don't do automated tests before.
No, nobody is saying that. So
I think it requires reiterating, because
okay,
there are different people on the internet, right? So that is that. And then you also, as a developer, if you were talking about developers, then you will also be happier because you probably will have better velocity, because there are less bottlenecks, and you're also fully in control of who can break your code.
I think an important point here is like when you're speaking about velocity, is that the source of this increasing velocity is actually reducing the feedback loop, right? When we make something, we immediately know how it goes, like if it breaks anything, and if it does, then we know where the problem is, and we're still in this context, and we're able to save on this context switching, and the feedback loop is really short, so we can go faster. Right. This is like basically the idea of all this like quality tools, like starting with static code analysis, with security tests, with integration testing, with anything actually.
I think it goes further than that. there was this paper, like a little bit. So that is true, of course, right? Shortening the feedback loops is one of the main sources of increased productivity. And also, like, it reduces frustration, because no one likes to like be at work and then be like, oh, 2 weeks ago you did something, like, and lucky if you 2 weeks ago, not 2 months ago, you did something, and now we figured out that it's broken, and now you need to go back and fix, right? So short feedback loops. There was this paper from I think researchers at Microsoft, and I will give you the link as well, who talked and looked into the developer productivity and developer experience.
Okay.
And developer experience is very, very hard. Maybe developer happiness as well, hard to measure, because it's kind of soft, right? Like, it's like, what does it mean to have a good developer experience? Everyone has an opinion on that, but it's sort of hard to pinpoint. And then they looked at different other research papers, how people define developer experience, and they tried to distill sort of the factors that usually are considered into this triangle of 3 main axes of developer experience. And they argue that those 3 main things that define developer experience are feedback loops and the speed of the feedback loops, cognitive load, and the state of flow.
Okay.
Right? So like when you're like, and then I think most developers would recognize that, yeah, if you can have fewer things in your head when you are working on something, you can go faster, rather than if you need to like think about like a million things. And then so that's cognitive load, and being in the zone, or the flow, is also true, right? When you start working on something and then you make progress, right? It's very, very easy to make a lot of progress. But if every small achievement gets like it gets to you like very, very it's very hard to make even small steps, right? Then you're frustrated, you are slow, you get interrupts, and then doesn't work. So like 3 pillars of developer experience are short feedback loops, low cognitive load, and what was the third one?
And the frustration.
Yeah, being in the zone, right?
Yeah.
So they didn't make this conclusion in the paper. I would say that all 3 are greatly impacted by the quality of your tests.
Yeah.
And unless you fix your tests, you will not get either of them to like a decent level.
Okay.
Right?
Okay.
So
we're not even talking about like the quality of the product. We're talking about the velocity of the developers.
And happiness.
And how integration tests actually unlock their velocity and productivity. Yeah, that's a great point. Okay.
Because like the cognitive load, well, of course the systems will vary in complexity, but if you have decent tests, right, and if you can change the system a little bit and see what breaks, right, or what changes in the grand scheme of things, or if you can make those incremental changes and kind of sort of go step by step, and you know that your system has your back, right? Like you have tested, so you don't have to remember about small details.
Right? Yeah, that's kind of a confidence everybody wants to have, right? Yeah. Not having a huge checklist with 25 points about like what to do when you're implementing a new feature, which requires like changing the database scheme, like updating one service, updating second service, updating, I don't know, a deployment config, and so on. Well, those integration tests will give it to you.
Yeah.
Okay.
So, and then and also the flow, right? Because like they very often people argue that you need better documentation for this, to know where to get information, to know where to get like the ideas, what has to happen in the system, and then like just write better tests. I mean, you still need documentation, but like a test will tell you much better, right? Leave your Friday. This is the advice. If you're listening to this, take this one thing. leave your Friday evening by writing a test and fails, and then you will come on Monday and you will run the stuff and the test will fail and you will fix it and you will immediately switch into work mode Monday morning, and your productivity will rise as a as a phoenix.
That's a great advice. Okay, I will include it in the short afterwards. Okay, but I think we're kind of reiterating on the same time, and time is going out. So like let's imagine we have a service, right? And it's speaking to Kafka, it's speaking to a database, it's speaking to 3 other services. Like how the ideal tests for such kind of a setup would look like, given all that was said before.
Right. So you have a system. Well, I would use test containers to sort of like set up the environment in a programmatic way for my that surrounds my application. That means setting up those external services or external systems like databases and message brokers and so on. And then would just exercise high level or like the highest level API that will give me the confidence for the application. So say I'm writing a small microservice like in Java, and it responds to, I don't know, HTTP requests, and it needs a database and a message broker for work, right? In my tests for my environment, I would create in containers a database. I will populate it with either snapshot and then database migrations that my project would use in production as well. I would set up my message broker similar to how I set it in production, or at least to like a sensible model of what is used in production. And then I would just run my application. My application would run normally. My dependencies, my service dependencies will run in containers. And then I would just make HTTP requests to it. Or I would send messages to my message broker and in the test, wait until my application reacts.
Okay, so basically what you're saying is that you need some kind of a tooling that would recreate the environment that is required for these services. Basically, all the dependencies that exist for your service, they should be up and running. And like, is it ideal if they're running locally or running in the same cloud environment that it will be in production? Or like how it works best way?
So, well, it doesn't strictly speaking matter where they run, right? For some, like, and it also there are confidence intervals, right? So for some services you want to use the cloud environment. For some services, for most services, I would say that you should be able to run them locally. It doesn't mean your development machine or your CI environment. The test containers approach is to run them in containers. And the test containers approach is to run them programmatically from the test within, making your tests self-contained, sort of isolated. That gives you a few things that you would really want to get. It would give you the full control over the life cycle of those. So you can keep the isolation between different, say, parts of your test suite, reusing the same infrastructure or spinning up a new infrastructure for themselves. Particularly, it will give you the control over configuring the services the way you want. For example, setting up the database schema in a particular way, or data for some tests, and so on. I can show you a quick example if you want.
Oh yeah, sure. Let's take a look if you have something on your hands. While you're on it, Artem is saying like unit tests are fast and easy to run. Agree. Test containers are great to check all that integration event with all various hoops, still taking time and breaking the zone. So you're saying that like test containers are slow and like doesn't have the same feeling as unit tests? Is that what I'm hearing?
Yeah, I think he's saying that. I don't think he's honestly 100% actually meaning that. I think this is like a cheeky comment about this. But let's look at the example, right? Let me share my screen. So
Yeah, go ahead.
right, so I have my IDE here.
Okay.
Right,
Okay.
I have like a massive letters.
So we're doing software development Joe Rogan right now.
Yes. This was not scripted. I didn't tell Vladimir that I'm going to be doing this. So let's see how it works. So I have my Spring Boot application, and it's a very simple like application. The actual logic of that is not even that important. It deals with products, sort of like an inventory thing, right? We have the products. We are exposing our application as the web service. You can query it. And it works with the database via this product repository Java class that would do something with the database. And then it works with Kafka to send messages to Kafka via Kafka template, right? So this is sort of the application idea. It could be something else, right? In my tests, so this is how a test with test containers would look like. Right, I would add the test containers libraries to my project. They will get there. It's super easy to consume. There is the whole ecosystem of particular modules for test containers, so I don't have to know how to run particular technologies in
a container.
In the container, right?
Yeah.
So I don't need to know how to run Kafka in the container, but in my code, I can just rely on this sort of abstraction that kind of gives me like all this, right? As an application developer, I don't want to know this.
Okay. So you're saying you don't need to be an SRE, like knowing how Kafka is supposed to work, like what parameters it requires for the configuration and so on. There are some reasonable defaults.
Yeah, there are some reasonable defaults. I can change them if I would like to, right? Or even better, because this is a library, right? This is a mind-blowing point here. This is a library, and the whole system comes, like this configuration comes in the form of a jar file. So as an application developer, as an end user, I can write stuff myself. There is a low-level API. So let me show you here. So for example, I can do a new generic container, and this will take a Docker image name, right? And then whatever Docker image you put in, this will be the abstraction that sort of works with technology in the container. And then on it, you can run, you can configure anything that actually, come on, please, Copilot. You are embarrassing me in front of the architect. You can configure anything that you can configure on a container, like environment, exposed ports, networks, the dependencies between different containers if you want to build a custom, more complex environment.
So this is some kind of like infrastructure as code. So some kind of similar to CDK.
Yeah,
like you're literally describing with code the environment you want to have in the test.
Yeah. Do you know Pulumi for AWS? Or for maybe not even that AWS Pulumi thing? Pulumi?
No, not really.
Okay, so this is the same, but like for infrastructure.
This thing you don't know about, like that.
Yeah. So, but like the thing is, I get the abstraction that I can configure and run any service that runs in a container, and I have the low-level API that I can use to say how to configure that particular container, which commands to run, how to limit the resources, and so on. Right? As an end user, I can use that API. So, for example, to run Redis, I can say Redis, and then something. 6 Alpine is probably fine, and then I can expose the port within the container, right? So my Redis will start, and that this would be Redis, right? I get my lifecycle methods, so I can do start or I can do stop, and then, for example, I can start it, And then, for example,
but the more important is how to fill the Redis with data.
Yeah, we'll get to that. You don't fill Redis with data. I mean, the application fills Redis with data, but we'll get to that point in a bit, right? But the thing is, I can run something in container. I can configure the containers. I can manage the lifecycle of containers, and then I also get the API to actually to actually get the information where my stuff is running.
Okay.
So I can take those return values for myself, and I can configure my application to use this Redis programmatically, right? I don't need to know in advance where my Redis is running. I can just create a Redis within my test, or like somewhere in the application lifecycle code if we talk about local development environment, right? And I can feed the information about that to my application. So I can do that. I can also rely on those technologies for the particular things, like, for example, for databases or Kafka that we looked at. And those can come from the community. Test Containers has the ecosystem of those modules for the particular technologies, but they also can come from other people on your team. So that SRE who knows the particular details, how they configure Kafka in production, can also give you the Java library where there will be like my Bolt Kafka container, right? And then that would be
that's convenient. Yeah,
that would be provided by your, like, usually it's not an SRE. Usually those in companies and in the projects where they do use such things, usually it's a platform engineering team. The team that is responsible for enabling developers to have better productivity by specifically doing those things, right? So I can provide an abstraction that would model how I run certain technologies in production, and give it to my end developers, my application developers, so they don't need to fill their brain with that information. They can still override it because it's just code, right? That's the beauty. When it's code and when you are a developer, you can do whatever, right? You are in full control. So you can do Redis, you can do Kafka. We can do, like, for example, Postgres. And then, actually, let me show you this. I don't think we're using it here, because here we use the database migrations for my database. So when my Postgres starts, right, in the container, and my application learns that, that is my Postgres that I need to be using, it will run the migrations because the database is empty, right?
Okay.
But that is specifically for database migrations. What usually you would do is technologies in containers usually are configurable with files. So there is also the API, for example, to copy things into container. So I can, for example, well, I don't have it here, but like this is actually a reasonable example that Copilot shows me. I can say I have a dump of my database with the schema and the data as well. So I can say I would like mountable file for, like, say, whatever resource, and then
okay. So basically at the company level or at the team level, you can have a repository with the test files, with some test sources, and then leverage those files for running tests.
Yeah, well, ideally those files would also come from the project itself, right?
Yeah, probably.
So I can control the particular details of the schema, and then it doesn't have to be the only way to configure this. This could be like a dump of my database that I renew on a weekly basis. So my database doesn't need to run like thousands of migrations every time I run a test, but I can also run just like a snapshot, and then the migrations that are missing in the snapshots will be applied incrementally with, I don't know, maybe like a few dozen, right? So, and then copying files into containers will, of course, configure not just the database. And this is the particular idiom that works with databases, where you put SQL scripts or shell scripts into the, this is, I think, by convention, this directory is used for many databases: Postgres, MySQL, Oracle. I think like a bunch of others for using those scripts at the startup to ingest the schema, right? But also, if I have my Kafka, or if I spin up my Kubernetes cluster in the container, if I need to work with the Kubernetes cluster, I will copy my configuration YAMLs there to set up to create the state for my containers. So that is that. I can also do more complex topologies. So here I can have networks, and I can, for example, run my Kafka and also my schema registry. And
wait a second. Like we have only 15 minutes left, and I think we're going like deep into the details of using.
This is amazing. I'm going to show it to you.
What I wanted to suggest is like let's try to run something. Like
okay, let's run something.
Please show me the test. What
here's
does
the
it
test.
What does it checks?
Oh, this test checks that if we here, the test that actually asserts something. This is a weird test without asserts. The test is that if we take the product, and if we update the name of the product, and then we'll find it again, then we'll actually change the data in the database. Fair enough?
Okay.
So I can run this. I can run this test, and it will start. What it will do, my test containers libraries will find my Docker environment, which could be any compatible Docker environment. Idea, go away. And then it will create the containers that I need to. If the container images are not present on my machine in my local cache, it will pull the images. You can also configure how exactly and where from it pulls, but it will start. It will follow the life cycle of the containers, and then it will start my actual application because it's a Spring Boot test, and then it will run the actual test code, right? So,
okay,
and it runs in like half a second, which is, I don't know. A unit test, a proper unit test that will just do like a little bit without any external things would probably run faster. But then again, I'm old and slow nowadays. So things that take half a second are decently fast in my book. And then, of course, for most of the tests, so like for this, like if I have those two tests, right, I will not create a separate database environment for this method and a separate database environment for this method, right? I will reuse my infrastructure that my tests create to a decent degree, and then I would run more tests, and I will run two tests, and it will take the same time, right? So of course there are some differences, right? If you work with
one second, I want to read a question. So if two microservices depends on each other, for example, order service and inventory service, should we run inventory service container in an order service, or should we mock the outcome of order service? That's a good question.
That's a very good question.
Well, yeah. The first question before that is like, why do we have like interdependency between others? But like, let's leave it to other session. So yeah, if we have two services depending on each other,
I assume this is a singular, like a one-way dependency, right? It's a one-way dependency.
Okay, maybe.
So like the normal case, a one-way dependency, right? And then, yeah, I would recommend mocking that service, unless it's something stable, as I mentioned, like config service, right? The config service, you put in a container, you do new generic container, my company config service, and you run it, right? And you depend on it, and it will never change. It will never change. It will never fail you. It will work beautifully. But if this is an inventory service and you depend on it, you should mock it out. You should mock it on the service layer. So there are a number of technologies that you can use within the test containers ecosystem.
Wait a second. So you're not suggesting having a container with other service?
Yeah, I'm suggesting having a container with a mock of the other service, which is much better. Insert the Johnny Depp, the plan of a key meme. Right. So, and there are some technologies.
Why? What is justification for such a setup? I thought like this integration testing is like we have one service, it depends on another service. We up a container with another service and we actually call it.
Yeah, but like if you start spinning up other services, they will bring their own dependencies to you. So you will need to spin up more and more and more, and then you will end with half a Netflix trying to be spin up for a test, and then inevitably something will fail in one of those, and your test will fail because you're spinning up the services, right? And then something will be
okay. So what you're saying is like spinning up the dependent services is not a viable strategy because you will end up with half of your environment up, and that will kill all those benefits that we were talking previously.
Yes.
And this is like kind of not an integration testing, but this is like up to end-to-end testing.
Yeah, well, and you can do that. And like, I think to a certain degree, it would work with certain projects, but this is definitely not a best practice. I would not recommend doing that.
Okay.
Right?
Thank
you. So it would work, right? And then you can use test containers as well to like sort of orchestrate your sort of end-to-end tests when you spin up multiple services and your tests are not even written in the language of those services, but like you are using something else to just like, and use test containers as an orchestrator. Like imagine replacing Kubernetes, but like you just do everything with a programmatic approach. But you mock services, and there are a couple of modules that you can use that. So you can use a wire mocking container to do wire mock of a service. You can also recently I started learning about Microx, which is a CNCF project for simulating APIs, mocking APIs.
Okay, what does it do?
Do you know what WireMock does?
Not really.
So like you spin up a service, and then you create sort of, you feed it stubs for you feed it information how to react to certain requests or what responses to send back.
Okay.
And this is like both like all those mocking technologies, whether you do it with Microx or WireMock or mock server, essentially your test itself would say like, I want a service that when giving those requests will return me that information. They differ in the particular implementation of how you configure them, and differ in the particular implementation how complex you can have those request responses. Can you do like chained requests where like I ask you for a thing, you return me, I send you additional queries by IDs that you just sent me, and like there is a or whether they support, like for example, async API. If I want to mock a service that I depend on, and I communicate with that service using, say, Kafka messages or SQS or something. Yeah. So, but the idea is that you don't mock the code in your application, cutting out the code path that might actually contain failures, and you don't spin up the actual real thing, but you spin up a model of the real thing, and you use your model for that service as a tool to communicate with that other team of what sort of the contract looks like. That brings us to the topic of the contract tests, which you might want to implement or might not want to implement. It's a separate topic, but like you create the mock, you define how it reacts to certain requests, right? Or certain actions, and you show it to the actual team who develops that service. And it's much easier to do with a mock because it's hard to talk to other people. And then when you actually have a thing to show them, it's much easier to talk to other people. You can be like, look, is this correct? So sort of like that. But you will spin up the same containers. You will those external services that you depend on will also have the same sort of the lifecycle approach that you use for your other infrastructure dependencies like databases or and so on, right? And then you would work with them. And if you, for example, need to mock some cloud technologies, then there are different modules that test containers uses. So for AWS, we would recommend local stack, which is the sort of the double of the AWS
Okay,
stack in container.
they're serving containers for the cloud services like DynamoDB and I don't know, cloud storage and all that stuff.
Yeah. And then for Google Cloud, there's the Google Cloud. We use the emulators that Cloud SDK provides.
Okay, that's
and then
nice.
We have something for Azure, but Azure is, at least I think the integration there is the least developed. So if you're doing that and you use those containers, consider, if you're using Azure, consider maybe
we need some Azure developer advocates like listening to this thing.
Contribute to the community, right? So, but it's, look, the tests run. Let me show you another thing. Why is it so good that my code is all programmatic, right? It's because I can also use the same, well, not this particular, I can also technically use the same setup for running in my application locally. So here I have my Spring application beans, and I configure my Spring application to use those services, which I could use in tests, but I can also just say like, oh, create me an application from those and use that container configuration. So I can run this locally. Now I'm not running the tests, but I'm running my application locally. And it will spin up the environment for me.
That's nice. So you're basically getting your environment without any additional, I don't know, writing Docker compose files.
Yes, exactly. And this is the same environment that I would use in my tests. So I can very easily to reproduce failures in CI locally, both within the test or with the local setup. Everyone on the team gets the same setup without actually remembering to run any external commands, or God forbid, install software locally, like a database or something.
Oh, that's nice. That means that instead of writing a README file, like spin up this thing, write this script, you just spin up a test application, right?
Yeah, you just say like, run this command to run application, boom, done. And this is like, it's not just Java specific, right? Like there is nothing Java specific in test containers. There are other libraries in other languages. So you can have the same approach with Go microservices, for example, by using, I think, build tags and init functions for the lifecycle, right? And you can create the dependencies programmatically. So everyone on your team will run the same setup. Everyone on your team can contribute to it. And then everyone will run sort of those high-level tests. So here, I don't know if my application works. Wait, let me see. Right here, API products. Do I have it? API products. Here, post. I posted something. Something happened, right? And then if I look here, where's my terminal? Right, if my terminal, I can see my services running, right? Test containers takes very good care of sort of the best practice. It randomizes the ports so I can run multiple services on it, and then but then programmatically I can use it very, very well. And I have this test containers desktop application that I can use additionally, which will provide me more tools to work with the test containers based setups. So here, for example, you can see that my Confluent control center is running on some random ports. This is the tooling. This is a tooling to monitor what happens in my Kafka thing, right? But because and then it would run on random ports because I don't want to fix the ports to avoid conflicts. But like with the test containers desktop application, I can, for example, fix the proxy to particular things, right? So here I can show you. Let me show you control center, right? I can say that anything that runs that via test containers, proxy internal port this to that local port, and then in my local host, right, local host command, this, I will get access to that on this stable URL. So I can use all those containers that I'm running locally as if those were running locally with fixed URLs, with a fixed connection string to go to my database from my ID or whatever, like database viewer, or here.
Okay, very good. Yeah.
If you're using test containers, check out the application. I think it's pretty sweet.
Yeah, we're running out of time. So the last question that I have right now, like, what are the 3 most common pitfalls in integration testing that you would recommend to avoid?
In integration testing in general, or in test containers?
In general.
In general. Right. So first, don't spin up your whole environment. Don't make your integration test an end-to-end test. Right. Second, very, very often integration tests are considered slow because you do need to provision this environment, and it can take like a few seconds for some technologies. It can take a little bit longer for like a heavier technologies, right? Use your judgment and use your common sense for thinking through performance versus isolation questions. Most normally, you don't need actually a super isolated environment for every particular test. I can very, very normally reuse the database for a number of test cases, right? And then what I would just like to have is the flexibility that when the time comes and I need an isolated environment for some tests because they are like sort of testing negative paths, right? And they will break something, and after them, the other tests will not run because they just, I don't know, broke Kafka or broke my database schema, right? For them, I want to have the flexibility to create isolated environments, but don't do it blindly for every single thing, because it's like then stuff can start getting slower, which will kind of sort of defeat half the purpose of this, right? And then the third thing is, I don't have a particular stance on test-driven development. Do whatever works for you. If you have tests in the same pull requests as the code, without the reviewer having to tell you where are the tests, you are doing test-driven development enough.
Okay. That's a good one.
I think.
Yeah, thank you very much. We're out of time. That was very insightful. Like, I saw how to do that. Like, we discussed the problems that exist in the integration test scope. So thank you very much. We'll leave all the links in the descriptions down below. And if you liked this interview and channel in general, don't forget to make a like, press the subscribe button, and yeah, share the channel with your friends and colleagues. Maybe they will find something useful as well. Thank you very much, and see you next time.
Cheers. Thank you.
Окей, я закончил стрим.